in Southern California in the United States. Astronomer Shrinivas R Kulkarni is on his way to Palomar Observatory. He's receiving the Shaw Prize for his contributions to time domain astronomy, which have revolutionized the field.
We are about a few miles away from the observatory at this point. We crossed the 5,000-foot mark, and the observatory itself, I think, is at 5,500 feet. So we will enter shortly the grounds of the observatory. This is the Cleveland National Forest. There's no urban area here, nor even houses, and the observatory was chosen to be away from the cities because of light. And here we'll turn, you can see Palomar State Park and the observatory.
Born and raised in India, Shri received a Master of Physics degree from the Indian Institute of Technology, Delhi, and a PhD in radio astronomy from the University of California, Berkeley, in 1983. He fell in love with astronomy in his teens.
It's an amazing job to get paid to understand how the universe came about.
Shri is a professor of astronomy and planetary science at the California Institute of Technology. Caltech owns and operates the observatory. Palomar Observatory is near San Diego, California. It houses the optical surveys that Shrinivas R Kulkarni created. Their groundbreaking discoveries are at the forefront of time domain astronomy. Time domain astronomy is about finding objects in the night sky that change over time, which are known as transients. They're caused by moving asteroids, stars dying, and stars changing in brightness. Astronomers find new transients by taking an old image of the sky and compare it with the new image of the same sky.
This is the old image. Look at the galaxy, there's a star here to give you a reference. New image, galaxy, a star here. But there's a new object here. And that's because that's a supernovae we've discovered.
And astronomers used to look at these images by eye.
You take one image and the other image and you flip back and forth, and the new object will appear like a blink.
Around the year 2005, Shri came up with an idea for a new type of optical survey from observing a Zwicky diagram. Up until then, most astronomers focused on two types of exploding stars.
One is novae, which is a minor phenomena on accreting white dwarfs. Other is supernovae. So they call them as supernovae because they are 10,000 times brighter than the novae. I wanted to know, as an explorer, if you look like this, what other things are in this diagram? Okay, it's a very basic question, is what, because the universe is so rich, maybe there are other things. It took me about 2 years to figure out a plan to undertake a very systematic and a powerful search of changes in the night sky at optical wavelengths.
The concept was to systematically survey the night sky and record transients over time. Fast forward to today, the concept is now a system called the Zwicky Transient Facility, or ZTF, and it uses two telescopes. This dome houses the first telescope. So Shri, what is this facility over here?
Well, this is the 48-inch Schmidt telescope, and it's the first telescope of the Zwicky Transient Facility. It carries a very large imaging camera, sort of like your iPhone cameras, but much better quality and almost a gigapixel. And this, with this, we survey the sky, the whole northern sky, in about 2 days. That's our main program. And we call this as the discovery engine because you image the sky, you compare the picture tonight with picture taken a year ago or a month ago or a day ago, and see if the new things have popped up. And we can find as many as 500,000 changes in the sky in a night. We can't study all of them. So we rank order them in importance of what we think the science is, and we can select of the order of 10 to 20 So for that, we need a second telescope to go and understand a bit more about these selected objects. And for that, we need to get a spectrum.
Inside this dome is a second telescope with a 60-inch diameter lens. It has a spectral energy distribution machine that measures the unique chemical signature of transients.
And that classifies whether it's an exploding star or novae or something else.
The entire process is automated, and the data from the telescopes is sent to the astronomers at Caltech and partner institutions around the world for verification.
And then when we process it, the data looks something like this, which is a bit more processed form of the data. And then we further apply our cuts. We correct for various things, such as different kinds of moving objects on the sky or different kinds of standard corrections. So this big bump is because of the presence of hydrogen in the explosion site. So from this, we can tell that since there's a lot of hydrogen present, it most likely is the explosion of some kind of a red supergiant star, which has around 10 solar mass of hydrogen present in it.
Shri's optical surveys have discovered tens of thousands more supernovae or exploding stars than the manual blink surveys.
The most productive supernova search was being done by Professor at Berkeley using the Lick Observatory. And they're finding about 100 supernovae in a year, okay, and classifying them. We are finding we have the capacity of about 20 to 30,000 supernovae in a year, and we are classifying 2,000 per year. That's a huge jump.
The Zwicky Transient Facility uses artificial intelligence and machine learning. And in October 2023, the system was able to independently recognize a supernova and announce it to the world without a human being involved in the process. Over in Princeton, New Jersey, the chair of the Shaw Prize in Astronomy Selection Committee said that Shri was chosen for the prize because of the impact he's had on time-domain astronomy. With the Zwicky Transient Facility and its predecessor, Palomar Transient Factory.
Time-domain astronomy is special now partly because the technology has developed rapidly to enable us to be much more effective at finding time-varying events. And one of the remarkable things that Kulkarni has done is to develop an automated system for the ZTF and PTF that's enabled him to transmit new discoveries to the astronomical community at large without human intervention and on a timescale as short as minutes.
Back in Pasadena, California, at the California Institute of Technology.
How repeatable will this arrangement be?
Mansi Kaslawal is also an astrophysics professor. She will be managing ZTF in the new year, and she says the discoveries made by ZTF have been crucial to understanding the fundamentals of life.
One of the questions that all of us think about is, where did we come from, right? And what are the elements, what are the building blocks of life? So when we look around us, we are made up of carbon and oxygen, there's calcium in our teeth. The majority of these elements are synthesized in cosmic explosions. And what ZTF and PTF discover are cosmic explosions.
Roger Smith worked with Shri from the very beginning, and he helped to build the optical surveys.
Shri is quite a visionary and comes up with a lot of new science ideas, and he's very good at seeing where new technologies might enable new science.
Shri calls his philosophy for scientific research opportunistic, because he likes to work on scientific problems that have a good chance of succeeding.
The universe is very rich. It's lived for a long time, produced many things. So with technology, I felt you could go and build a machine and learn new aspect of universe on a timescale of 5 to 10 years.
Well, ZTF has been very successful. Shri is looking forward to a new research project in time-domain astronomy, funded by NASA, to study the sky in the ultraviolet.
But to study ultraviolet, you have to go above space because ultraviolet is absorbed by atmosphere. My main interest in that mission is more to study the matter between stars, what's called interstellar medium.
At home, science is never far from Shri's life. His wife has a PhD in biochemistry. They met while studying at the University of California, Berkeley.
So she was very focused on science and understood the importance of being a scientist. I felt that she would understand why I'm so focused.
Hiromi Komiya understood that Shri's work would take him away from the family.
So I wasn't really surprised about what he had to do, but still, he had no holidays. It was like no weekend, and whatever time he had, he was doing work. And when he was exhausted, he would sleep 3 days in a row. And
His elder daughter, Anju, says the family supports his career so he can do what he loves.
And there's a lot of people who put so much effort so that he could have this career doing what he loves, even though it comes with a lot of sacrifice. And I definitely hope that whatever he does next, he really does sort of in the same spirit, learning more about the world in whatever way that he wants to learn.